Two sides and an angle are given. Solve any triangles that results. Please round to the nearest tenth if necessary. All right, A, B, alpha. Now you can try to solve by drawing the picture and seeing what kind of picture you're going to have, or you can start to think through law of sines, law of cosines. Either way, what I notice is we have A and alpha. We have an opposite pair. Anytime you have an opposite pair, you can use law of sines. Now, law of sines can give you multiple triangles when you use it. However, setting up, let's see, we have B, we don't have its opposite pair, beta. Let's set up this law of sines. It would be sine beta over B equals sine alpha over A. So this is sine beta over 9 equals sine 65 degrees over 13. So this would give us sine beta equals, now on your, let me do an arrow there. There we go. On your calculator, make sure you are in degree mode, and it gives you 0.627-ish. I'm not going to ask you to type in 0.627 though. You have all of the information on your calculator, or at least you should. So 0.627443853. The calculator even has more information than that. I want you to make sure you're doing arc sine, so second sine of the answer, not of the 0.627, the full answer. It gives me 38.86. Okay, so beta is, now I'm going to write this one down with some extra information, 8618. Now, although they're only asking us to round to the nearest tenth, I'm going to have to use this beta to find as something else. So I want to have extra information. In the last answer, I will then go and round. I don't want to round too early. We now have beta. Now, could this beta also be, and this is, are you in a two triangle situation, sine, let's see, if I take 180 minus beta, I get 141. It's possible the beta could also be 180 minus 38.8, 141. But I'll tell you why it isn't. This is how you would get a second triangle if you could. I'll tell you why it isn't in this case. B is smaller than A. So the angle opposite, beta, will be smaller than the angle opposite, alpha. The time when you might get more than one triangle, when you get like the first quadrant angle for the arc sine, and then you have to do 180 minus that and maybe get another one, that's only if the opposite side is the largest. We're working with B, that's smaller, it's not the largest. So I know 38.816, let's make degrees, is correct. Now we need to get gamma. Gamma is 180 minus alpha 65 minus beta 38.861. And that gives us, let's check it, 76.1382. 76.1382 something degrees. All that's missing is C. Okay. Now, 76 degrees is the largest of our angles. So the opposite of that, C, will be the largest of our sides. Just a side note, so you can look at some patterns. So law of sines, C over sine gamma equals, I want to use the original information as much as I can get, so I'm going to use A and sine alpha, because that information was given. I know what's going to be correct. So this gives me C equals A sine gamma over sine alpha. All you have to do is multiply by sine of gamma. It goes up here and you have solve for C. So C equals A, 13. Sine gamma, 76.1382. Run out of room with the stylus, sorry. Over sine alpha. So make some more room. This gives us, now you go to your calculator, and get 13 times sine of answer divided by sine of alpha again. Well, I didn't put in alpha, that's fine. Alpha is 65 degrees, so right here, that's 65 degrees. I don't know if I can erase that a little bit. Nope, I can't. Okay. Oh man, come on, come on. There we go. Sine 65. Final answer, 13.926. And that's not a degree, that's a side. So we would now give beta is 38.9 degrees, gamma is 76.1 degrees, and C equals 13.9. These are rounded to the nearest tenth. And by the time I got to C, I had used C gamma. I had used this gamma. This gamma, I needed to use beta to get it. So this beta, I went with 4 decimal places because I knew I was going to use it again and use it again. And the more times you use a mistake, the worse it gets. This is a mistake. This is an approximation. It is not perfect. In fact, if you know how to store multiple values on your calculator, I would store beta here. Then I do 180 minus, then I do 180 minus 65 minus the recall value and get this. And I'd store that in another spot. And then here I would have 13 times sine of this store value divided. I would not approximate at all until my final answer. Since I didn't do it that way, because I don't know if you know how to store multiple answers on your calculator, I just made sure I had a lot more information than I needed to end up with. So I felt confident this is good to 4 decimal places. This is probably good to 4. This might only be good to 2 or 3 decimal places. But by the time I round, this should all be still good to 1 decimal place. I hope that makes sense. We have solved this triangle. And let's move on. Vectors. V, 3, -1. W, -2, 4. So what I would do on this problem, first off, V, that would be 3, -1, minus 3 times W, -2, 4. I don't like subtracting vectors, so I would take V, which is fine, and I would distribute this -3 into the vector, so I can just have plus vector. That would be 6, -12. I like to add vectors personally. Now we just add components. 3 and 6 is 9. And -1 and -12 is -13. Easy, easy. Absolute value of W. This is the square root of the sum of the squares of the components of W. This is just Pythagorean theorem. How long is the vector? So that would be equal to 4 plus 16, which is square root of 20, which is, let's see, 4 times 5, so 2 square root 5. Please simplify your answers, so that's why I simplified from here to here. But give exact values, so I do not want decimals, so that is what I want. Okay, V dot W, dot product. Dot product is an operation that will give you one final real number answer. It is the first times the first plus the second times the second plus the third times the third plus the fourth times the fourth, depending on how large your vectors are. In this case, they're just two-dimensional vectors. So the first times the first, always plus, the second times the second, and we get negative 6 minus 4 is negative 10. Now the dot product can be used, for example, if the dot product is 0, we know that these are perpendicular. Things like that. But just to find it, that's that. It's done. This is the easiest question for a while. All right, let's move on to the next one. All right, problem 13. The lengths of three sides of a triangle are a equals 4, b equals 10, c equals 9. Find the measure of the angle beta in degrees. Okay, now whether you should use law of sines or law of cosines, it's all about whether you have an opposite pair. Since we don't have any angles given, we don't have any opposite pairs, so law of sines is not useful to us. So we go to law of cosines. Now we want beta, so cosine beta equals. Now the opposite pair of beta will be b. That's the one that's going to be minus b squared. All the rest are a's and c's. So a squared plus c squared and 2ac. And just plug stuff in. See what we get. Cosine beta equals 4 squared plus 9 squared minus 10 squared over 2 times 4 times 9. Now, so your calculator gets this correct, put a parenthesis on the top and parenthesis on the bottom. And then you just type it in. This is what we'll get. Plugging stuff into your calculator, you end up, oh, wrong color, equals negative 0.0416, repeat. But we're going to do arc cosine, so you don't have to worry about writing it down. This is just so you can check and make sure you're doing this correctly. Now, what mode should we be in? Why, we should be in degree mode because they asked for degrees. I am in degree mode, so arc cosine of the answer will give me beta. Beta equals 92, round to the nearest tenth, 0.4 degrees. Now, if they asked us to finish solving this triangle, since we have beta, we have b, that's the longest side. We also have an opposite pair, b and beta, so that we can go after like alpha and a, it's opposite with the law of sines. And then we can get gamma by 180 minus beta minus alpha. Something like that. But since they just asked for beta, we're done. So we move on to the next problem. Number 14. Perform the indicated operation, that would be division. Write the answer in the form a plus bi, so complex numbers. Give exact values, do not use decimal approximation. So I shall put my calculator down. Okay, well, this is De Moivre's theorem. We have complex numbers. Notice the I, top and bottom. So this is a complex number in trigonometric form. Complex number in trigonometric form on the bottom. This 14, now we don't need to do this work right here that I'm going to show you, but basically 157 degrees is about there, and out 14, this dot right there is the complex number that they're talking about. But that's just so you know where to go and that this is the trig form. What we really need to do is understand De Moivre's theorem is you divide the magnitudes of these complex numbers, or the absolute values, the 14 and the 7, the R values, and then you subtract the angles. I don't have enough room, plus I sine, same thing, 157 minus 127. And then we simplify. So make sure the top one minus the bottom one. So you subtract angles, you divide magnitudes. Okay, let's see what we get. So 14 divided by 7 is 2. And cosine 157 minus 127 is 30. Plus I sine 30. This is why we don't need our calculator. We have a nice unit circle angle. Cosine of 30 is square root of 3 over 2 plus I. Sine 30 is 1/2. We can now distribute the 2 through and get square root of 3 plus I. This is the form that they want, a plus bi form. A is square root of 3, b is the invisible 1 out in front, I. There's your a plus bi. No calculator needed, pretty simple problem. And again, this picture is just to remind you of what this form means. It's just one point in the complex plane. Alright, next problem. Convert the complex number to trigonometric form. Alright, 2 minus 2i. First off, where is 2 minus 2i? It's right there. So that point, we can draw this triangle. Well, that's 2 and that's 2. We need to find a couple of things. We need to find that angle, and I'm going that direction because our angle is specified 0 to 360 degrees. Now, if x and y are equal, I know this is a 45-degree angle. So if this is 45, and all the way around is 360, that means that this must be 360 minus 45, or 315 degrees. Theta equals 315 degrees. That would be a 45-degree angle in quadrant 4. Now we also have Pythagorean theorem, call it R. R squared equals x squared, 2 plus y squared, 2. 2 squared plus 2 squared. That's 4 plus 4, that's 8. I said 4 and wrote 4, sorry. 2 squared. And pencil, there we go. So that is 2 squared plus 2 squared equals r squared. And now I've got an equals problem. Man, I am having fun with this. Oh, and now it won't give me any eraser. That's an equals. Alright. Craziness. R equals 2 square root of 2. That's the square root of 8. Okay, so our form. Now if you forgot trig form completely, well, you can look at the last problem, 14, because they were all in trig form, which is nice. But it is the radius or magnitude of the vector or the absolute value of the complex number out front, and then cosine of the angle plus I sine of the angle. That's trig form. Done. Now, hi, just a second, Ben. This should be a 5, so make sure you see that that's a 5. I'm going to mess it up now, but that's a 5. Wow, I did mess it up. Okay, just one moment. Okay, now that we have our trigonometric form for part A, part B is asking us to use the trigonometric form from part A and De Moivre's theorem and leave the answer in trig form, that's nice, to find this, which is our complex number to begin with, but cubed. Alright, so now I get a chance to rewrite this thing proper. Cubed. 2 square root of 2 times cosine of 315 degrees plus I sine 315 degrees. There we go. We need to remember how De Moivre's theorem works. Essentially, De Moivre's theorem, this 3 outside, distributes in a way. And the way that is it is still a power on the magnitude of this complex number, and it multiplies the angle. So that's how the 3 distributes inside. This will give us 2 squared of 2 cubed. We can distribute the 3 and get 2 cubed and square root of 2 cubed. We'll work that out as we go on. Cosine 315 times 3 is 945 plus I sine 945. Alright, so now if we take 945 and subtract 360 so that we can get back to a regular answer, calculator, 945 minus 360 is 585. And subtract another 360 from that, 225. There we go. Now, on this problem, note that we want to leave the final answer in trigonometric form. So I'm not actually going to be finding cosine of 225. I'm going to be leaving it as cosine of 225. Otherwise, I'd go into 225 as a 45-degree angle in quadrant 3 where sine and cosine are negative and all that stuff, and we don't need to do that. So cosine of 225 degrees plus I sine of 225 degrees is the correct part. That's going to be in our final answer. We just have to figure out what do we do with this stuff. And what we do with that stuff, let's make a little room. 2 cubed square root of 2 cubed is just 2 times 2 times 2 times square root of 2 times 2 times 2. And this reduces as another 2 outside. So we have 2, 4, 8, 16 square root of 2. 16 square root of 2. And because the maker of this final was nice enough to tell us we could leave it in trig form, that is our final answer. Awesome. Let's move on to the next problem. All right, parametric equations. List at least 3 exact points on the curve. All right, when we are trying to graph parametric equations, it is nice to get an x, y set of points, but we have to use t to get there. We have the values for t, 0 to 4. So let's be fair and go 0, 1, 2, 3, 4. That'll give us 5 points. We only needed 3, so that's plenty. Let's see what we get. So plugging in 0 for t right here. 0 minus 1, negative 1. 0 square root of 0, 0. Plugging in 1. 1 minus 1 is 0. And square root of 1 is 1. So far we have negative 1, 0 this point. We have 0, 1 this point. Plugging in 2 isn't as nice because 2 minus 1 is 1. That's nice. But square root of 2 is not very nice. I know it, calculator, 1.4-ish. So 1 and 1.4, oh, about there, not exactly. 3, we get 2 and square root of 3. 4 is the next one that's nice. Plugging in 4, 4 minus 1 is 3. And 4, square root of 4 is 2. That point is 3 comma 2. What we're getting is a piece of a parabola. I want to do this justice. I'm going to expand this a little bit and move it around. There we go. That'll do it. Let's see if I can graph this one. Nice. Ah, that's pretty nice right there. And an arrow to indicate the direction of time. Some books use it. This book doesn't, even though I know a lot of teachers are emphasizing it anyway. And solid dot at the end, and solid dot at the end, beginning and end, I should say, because we have 0 and we have 4, but we have the equal signs. We want to label a couple of points. Negative 1 comma 0, 0 comma 1, 3 comma 2. These are the points where the square root worked out nicely. That's very convenient because they only asked us for 3 points and there's only 3 nice points to begin with. So that would be the graph. List at least 3 exact points on the curve. Excellent. Now if you had to, and you don't need to do any more on this problem, but if you had to, we could actually take and solve for t. So if x equals t minus 1, that means t equals x plus 1. If y equals square root of t, that's actually y equals square root of x plus 1. This is a square root of x left 1, which is exactly the graph that we have. However, the y equals square root of x plus 1 would exist and it would continue on forever. We don't want that. If we were to square both sides, we have y squared equals x plus 1, or x equals y squared minus 1. This is a y squared parabola, left 1, so that would be this. I didn't mean to write it in red and now it won't let me erase. Oh, actually, I bet I can erase just that layer. Crazy program. Okay, good. This parabola, we're only getting a piece of that parabola because of this 0 and 4. So now, although all that work is not necessary, if you had to convert from one form to another, that's the kind of work that you would need to do. All right, moving on. Forces of 3 pounds and 11 pounds act on an angle of 58 degrees to each other. Find the magnitude of the resultant force. So we have a force 3 pounds, another force 11 pounds, acting with a 58 degrees in between. What I'm going to do with this, let's see, draw an angle. I'm going to do with this is make a parallelogram. At least I'll try. There we go. The resultant force is this force. That's the force that we're trying to figure out the magnitude of to the nearest tenth. Include appropriate units, and be pounds. All right, so with parallelograms, so we know this angle is 58. The opposite is also 58. So that whole thing is 58. Now we also know that the four angles, 1, 2, and the 58s, add up to 360. So unknown, I don't know what that angle is. I'm just call it theta plus theta, oops, plus 58 plus 58. That all equals 360 degrees. The four angles of a parallelogram add up to 360. So that is 360 equals 2 theta plus 116 degrees. So 2 theta equals, subtract that, what do we get? 244, giving us theta equals 122 degrees. Whoa, that's a big old degree sign. Let's, oh, come on, erase that. Oh, now it won't let me erase. Crazy program. Degrees. Now it won't let me write. I'll get there. Degrees. 122 degrees. So let me highlight our triangle as is. About like that. Where this is 11, and this is 3, and this is unknown r, and this value 122 degrees. That's what we've converted this problem into, a triangle, where we have side, angle, side. SAS, that's a law of cosines problem. Excellent. Also, the only angle we have, we don't know the opposite. And we only know one angle, so we can't find the other two easily. We do not have an opposite pair, so we can't use law of sines, leaving law of cosines. All right, law of cosines. R squared equals the other two, 3 squared plus 11 squared, minus 2 times the other two, 3 and 11, and cosine of the opposite angle, or the angle between the 3 and the 11. Cosine 122 degrees. All right, it's looking great. Now we need to work all that out and square root. So on to the calculator. Make sure you're in degree mode, and you get r squared equals 164.97 stuff, and square rooting the answer leaves us with r equals 12.844 something. Let me take a look at round to the nearest tenth. I'm looking right here, and include appropriate units, which will be pounds. Make sure I have this labeled correctly. Round to the nearest tenth, so this would be 12.8 pounds. That would be our final answer. Some of you might have also seen this problem using vectors. The issue with vectors is, since we only know a general 58 degrees in between, you have to be careful with how you align these vectors. I'd probably put the 11 on the x-axis, and then the 3 up like this, and then that's 58 degrees. Then I can convert, for example, the 11 into vector form as 11, let's see, x, y, 11 comma 0. And then you can use x equals r cosine theta and y equals r sine theta to get this in vector form. And then I can use the angle between two vectors formula, which is also a cosine formula with a dot product and magnitudes. There are other ways to do this problem. The triangle approach is a nice way to go, and that's the way this book emphasized that we're teaching in Salt Lake Community College. So that's the way I chose. Okay, moving on. A hot air balloon is between two spotters, or 1.3 miles apart. Alright, so we have 1.3 miles apart. Hot air balloon, let's put it up somewhere here. And these two spotters, notice, one spotter 65, the other 72. This would be, in my picture, the 65. This would be the 72. It's a little bit longer, or sorry, larger angle. Okay, great. What does this give for us? Without reading the rest of the problem, I can already determine the third angle, because 180 minus 72 minus 65 is 43. We have 43 degrees. We now have an opposite pair. So we can find any other side we want. We can solve this triangle, said another way. Totally solve this triangle. Now let's read through the rest of the problem and see what else we might need. What is the altitude of the balloon? That's what they want to know. Let me draw the altitude. H. That's what we're trying to find. Now if I were to just draw, let's say, the right side of this triangle, notice what we have. That's all we actually know on this triangle right now. We're trying to find H. Now, if this is a right triangle, the altitude always gives us right triangles when we're working with it. So regular right triangle trig, sine, cosine, tangent, we need opposite over something. So sine of 65 is opposite over a hypotenuse, but we don't know the hypotenuse. Cosine is opposite, or it's adjacent over hypotenuse. That doesn't even use H. Tangent is opposite over adjacent, but we only know the angle. Sine is going to be great. This side of our right triangle is matching up with this side. And I've already talked about we can solve this whole triangle, so we can find this side, which means we'll have this side, and we can use a simple sine to find H. However, watch out this. We know this is 1.3. We do not know how far this is. And that's not a part of this larger triangle, so we wouldn't be able to just easily find that. So this side is something we can't easily find directly. But this side is, and that will be our hypotenuse, and then sine will get us H. So let's go back to this one and find this value. We now need to find this value, because that is the same as that. All right, let's do it. Let's call it A, just because. We need a little more room. Let's check miles. Oops. Undo is not working anymore on this one. Let's try that again. There we go. To find A, I can set up a law of sines. A over sine of the opposite, 72 degrees, equals B, or whatever, one of the others, 1.3, over sine of its opposite, 43 degrees. This gives us A equals 13 sine 72 degrees divided by sine 43 degrees, which is, go to our trusty calculator, make sure you're in trig, I hope you're in trig or you're not watching this video. Make sure you're in degree mode. Oh, I noticed one mistake I made. Let's make sure, sorry, 1.3, okay. And the answer in the calculator is 1.813. Oh, where's my pen? There it is, 1.813. That's this value right here. I want some extra decimal places because when we round to the nearest tenth, I want to make sure we're still right. However, don't clear your calculator. We have 1.812868686 on and on and on and on. And I'm going to use that value when I do my next evaluation. So don't clear your calculator. Alright, so now we're looking at this triangle. We have enough information to use a basic sine. Sine of 65 is, since it's a right triangle, opposite over hypotenuse. Let's see what we get. Sine 65 degrees equals h over 1.813-ish. Multiplying by the 1.813, we get h equals 1.813-ish sine 65 degrees. Now to go to your calculator, do not clear it. You have the 1.81286868868. You have the full value here. Don't lose it. Multiply it by sine 65. So times sine 65. And we get our answer of h equals 1.643, but to the nearest tenth, 1.6, and the units, miles. Miles, because we already had the units and the nearest tenth. Let's take a look at the instructions, make sure we've answered what we need to do. Here we go. Please round your answer to the nearest tenth and include appropriate units. And again, we had miles. That's the only thing we had. So our answer, 1.6 miles. Excellent. Moving on. Graph the polar equation. List at least 3 exact r, theta points that lie on the graph. Now it says list, so we can put this on the side. We don't have to label and put it on the graph. Sometimes that's a little bit messy, but we can list it. That's fine. I'm going to make a chart. The way I do it is theta r. It's kind of opposite order, but I'm plugging theta in and getting r out. I'm going to start at 0, then I'm going to go to pi fourths. Let's see, pi fourths. Yeah, sure, pi fourths, and then pi halves, and then 3 pi fourths, and then pi. Hopefully by that time I can start jumping and go to 3 pi halves and 2 pi. I just want to make sure I have enough points. I might see what this thing does long before all these points are done. Starting off, 0. We plug that in for theta. And we get 3 cosine 0. Cosine 0 is 1. 3 times 1 is 3. Fine. Plugging in pi fourths. Cosine of pi fourth is square root of 2 over 2 times 3. We get 3 square root of 2 over 2. Okay. Pi halves. Plugging that in. Cosine of pi halves is 0 times 3 is 0. Excellent. Let's see how far this has taken us so far. So in the 0 direction, so out in this direction, we're out 3. So we go to 3 right there, and that will be our point. In the pi fourths direction, we're out 3 square root of 2 over 2. I'm going to approximate this with my calculator, and I get 2.12. So this is approximately 2.1. So again, in the pi fourths direction, we're out 2.1. So that would put us 2.1 about there. A little closer. That's close enough. And then in the pi halves direction, we're at 0. Puts us right at the origin. So what we have is a graph that's going in this direction. So far, that's what we have. Excellent. Let's keep going. Plugging in 3 pi fourths into cosine. Cosine's negative in quadrant 2, so we'll get negative square root of 2 over 2 times 3 is negative 3 square root of 2 over 2, which is approximately negative 2.1. Pi. Plugging in pi. cosine of pi is -1 times 3 is -3. Let's see what that gives us. So in the 3 pi fourths direction, going out in this direction, we're at -2.1, so we're facing in that direction, but we're walking backwards -2.1, and we get to here. Facing in that direction, but walking backwards gets us to here. Right. Facing in the pi direction, but walking backwards 3, puts us back to our original spot. We've completed a full circle. And now we're going to repeat ourselves back and forth. It's going to go around and around and around this circle. And we have our graph complete. And we have 1, 2, 3, 4, 5. We've listed 5 exact points. Here's the exact parts. We've approximated. If they're like, ooh, they approximated, take points off. Well, we still have 1, 2, 3 exact points. So we're good to go. We have our graph. This is a circle. Okay. That completes that picture. Excellent. If you wanted verification that this is a circle in another approach, you would have to convert from r theta polar form to xy Cartesian coordinate form. And that would be done in this fashion. Now, none of this work is necessary for this problem. But if I were to multiply by r, I would have r squared equals 3 r cosine theta. R cosine theta, that's x. R squared is x squared plus y squared. X squared plus y squared equals 3x. We are getting closer to being able to take x squared minus 3x plus y squared equals 0, and completing the square, adding 9/4. It's kind of messy, but it's okay. Getting an x minus 3/2 squared plus y squared equals 9/4. This is a circle with the center at 3/2 comma, oh no, erase. Oh, it's going to mess it all up. Here, let me go back. That was -3. Come on. Okay, let's try again. Center at 3/2 comma 0, right there. Radius 9/4 square root of that is 3/2, so left and right, up and down. This is just a circle. That work would be to check your answer. There might be another final where that's the question that they ask, convert to x and y coordinates, in which case I'd probably get to here and stop. I went all the way to here using some algebra so you could see that this in fact is the circle. Center 3/2 0 and radius square root of that 3/2. It's interesting to note, and one other note about this. First off, none of that was necessary. So if you're reviewing this, to answer our questions, none of that was necessary. I'm just doing a little extra review for you. But for plotting points, every so often stop and see how far you've gone. You might be able to pick up on patterns. Once we got to here and then here, I've done a full circle. It's just going to keep doing that full circle. And you could check if you needed a little more. 3 pi halves. Cosine of 3 pi halves is 0. 0 times 3 is 0. Cosine of 2 pi is 1 times 3 is 3. This would get us in this direction, go 0. In this direction, go 3. We're just going around again. Alright, enough of this one for sure. Let's go on to the very last problem on this final and be done with this review. Oh, they're going to make us work for the last one. This is a work application. A solid steel ball is placed on a 12-degree incline. Okay, so we have a 12-degree incline. Let's get horizontal. Let's get 12 degrees. 12 degrees. A solid steel ball. Okay. If a force of 5.8, oops, there we go, pounds in the direction of the incline, so parallel to the incline, is required to keep the ball in place, then what is the weight of the ball? All right? Now the weight is straight down always towards the center of the earth because that's what's pulling. The perpendicular to the incline is this, and that's going to be the force that affects friction. When you get into physics, that's going to be the one that you have to work with when you can no longer neglect friction. The parallel, the plane, this parallel, if you draw that same vector right here, you've completed a nice right triangle. This right triangle, as you can see, you don't need any of that, but I just drew it long just in case. This right triangle has 5.8 here. X for this side, that's the weight, that's what we're looking for. And now we just have to figure out what are these angles. We just need an angle, and we can use regular trig. And we have this 12 degrees. Okay, this is how you could approach. Let's see. All right. This line and this line are parallel, making this a parallel bisector. So this angle is equal to this angle, because again, parallel bisector. This angle equals this angle. This angle plus this angle equals 90 degrees. This angle equals this angle. So this angle plus this angle equals 90 degrees. So this angle and this angle are the same, because this angle and this angle have to add up to 90, and this angle and 12 degrees. I guess we could go, and this is saying this is 68, so since that's 68, that's 12. One way or the other, you finally end up with this. And let me expand this, because I'm going to have to be able to write it a little better. There we go. A little too big. Well, we'll get it in there. This is 12 degrees. This one. Okay. Now you probably won't need to redraw the triangle. You can work with what's there, but I want to highlight exactly what we're working with here. We have 12 degrees here. We have 5.8 here, and we're looking for x. Right triangle. From the 12.8 degree perspective, opposite and hypotenuse will give us an equation for x. This is sine. Sine 12 degrees equals opposite over hypotenuse. Okay, multiplying by x gives us x sine 12 degrees equals 5.8. So x equals 5.8 divided by sine 12 degrees, which is, calculator, 27.896. 4592. Let's take a look at what we need to write for our answer. Nearest tenth, include appropriate units. The units again are pounds to the nearest tenth. That's what I needed to see. So our final answer is to the nearest tenth, 27.9 pounds. Okay, that completes this review. I wish you luck on your final.